All right, guys, task number 3 lesson. We're finishing up with the properties of logs, and we can use the properties of logs to do the change of base formula, which is the theme for today's lesson. If you still have your definition sheets and you haven't already gotten them out, go ahead and grab them. We're going to add this to our notes. So before you write anything down, because I'll write it down with you, just note that these are used when we don't have the ability to do base 10 or base E, which are the only two that show up on your calculator. So here you can see this is natural log, that's base E, and if you have log on your calculator, that's base 10. So there is a way that we can use our calculators using the change of base formula. And it doesn't matter which we use. We can either use log base 10 over log base 10, or we can use natural log over natural log and get the same thing. All right, so I'm going to switch to the definition sheet. And our word is going to be the change of base. And let's add formula, because it is kind of a formula. And this is for non-base 10 or E logs. So let me zoom in a little bit, maybe that helps you see it. Okay, so if we have the log of some base B, anything other than 10 or the natural number E, of some value A, we can find it by taking the log of A. And notice I didn't write any base here. That means it's log base 10 all over log of B. We could also use natural log of A all over natural log of my base. So you're either using base 10 or base E. It's the log of your value over the log of your base. All right, so if we had an example, we would have log base 8 of 70. So I would take the log base 10 of 70. So I just write log 70, and I'm going to divide that by log of base 8, of log of 8. It's also base 10. And if I put this in my calculator, I would see that I got, let's clear that so you guys can see better. I would take log of 70, make sure you close that parentheses there before you hit division. And then you want to have log of 8. And there you get approximately 2.04. So our approximate answer is about 2.04. All right. I'm going to show you one last slide on this because it is fairly basic. We're just going to look at log base 3 of 29, and I want to show you how you get the same value whether you use log base 10 or log base E. So if we rewrote log base 3 of 29 using base 10, we would have log of our value 29 all over log of our base 3. And if I put that in my calculator, I get log of 29 divided by log of 3. I get it's about 3.07. I round up when it's 5 or more. So this is approximately 3.07. Let's try that with natural log. Let's just see what we get there. So same thing, instead of using log base 10, I'm now just going to say, well, I could also try natural log of that value 29. divided by the natural log of that base 3. And let's see what we get when we put that in the calculator. So I'm going to be using ln this time. So natural log of 29, still important to include that parentheses. And then we want to divide that by the natural log of 3. And I can see I get the exact same value. So it doesn't matter as long as you're consistent. So again, this was approximately 3.07. All right, that's it. It was a short and sweet video making up for task number 2's video, which was longer.